Hi, welcome back to another OCR MEI past paper walkthrough. This is C2, Core 2 for June 2013 or May 2013. So this video will cover section A. So question 1, find dy by dx when y is equal to 2x to the power minus 5 and y part 2 is y equals to cube root of x. So for this one, it's just simple drop the power and power take 1. So 2x to the power minus 5 times the power, which is minus 5, and the power minus 1, minus 5 minus 1. And that will give us minus 10 x to the minus 6. So that's the first bit done. The second part is the cube root of x, which can be written in index form as x to the power of a third. So dy dx will be drop the power a third, x to the a third times subtract by 1. So it would be a third x to the power of negative 2/3, and that would be sufficient for your 2 easy marks. Turns out this is 5 marks in total, so that would be absolutely fine. 3 marks, good stuff. Question 2, nth term of a sequence un is given by this expression, and write down the value of u1, u2, and u3 and state the type of sequence. And also find sum from 1 to 30 of this sequence. Okay, so for this one, first find u1, u2, and u3. In respective cases, n is 1, 2, and 3. And so u of 1 will be equal to 12, take 1 times the half. u2 will be 12, take 2 lots of a half. And u3 will be 12, take 3 lots of halves. And for each of them will respectively equal to 11.5. I'll turn it into decimal now. This is just 11 and this is 10.5. And as you can see, for each n, it drops by a half. And so this is a arithmetic sequence. And so the sum of this whole thing will be just using the sequence sum equations. First of all, we have sum to 30. This is part 2, by the way, and I've done that up there. So start from 1, and we have 12 minus a half of n, and you can break that bracket open and just multiply in the sum, so that you get sum of 31 of 12, take sum of 31 of a half n. Sum of 30 of 12, that is just 30 lots of 12, because there's no n term or r term or whatever you want to use in there. So that is just 30 times 12, and take this. However, the half can be taken out, so you get half of the sum of 31 n's. And 31 n, the summation of n is n times n plus 1 over 2. And so first, this is just 360, take a half of, because now n is 30, we have 30 times 31 divided by 2. And that's just 360. Take half of that is 15 times 31, which is very not helpful. I just use a calculator for this, because these are not easy numbers to do some multiplication in your head, and that will end up as 232.5, and so the total sum will be 127.5, and that is the second question done. So next up, question 3, the gradient of a curve is given by dy by dx equals to 18 over x cubed plus 2, and the curve passed through point 3, 6, and find the equation of the curve. So that's integration. So to do simple integration, it's just adding the power by 1, then divide by the new power, which is the reverse of differentiation. So for this one, first put it in index form, 18 times x to the minus 3, because it's 1 over x cubed. Then add 2, stays the same. This is still dy by dx, and so if after you integrate, you add the power by 1. Add the power by 1, so you get x to the minus 2. And you still got that 18 in front, but now we divide by the new power, which is minus 2. And for this 2, we have actually x to the 0, so we just add 1 to the power x to the 1 divided by 1, which is just x. So 2x is the next bit, so 18 divided by minus 2 is minus 9, x to minus 2 plus 2x. And if you want, you can differentiate this, and I'll just do it fast here. dy by dx is just drop the power, that is minus 2 times minus 9, which is 18x to the minus 3, because power subtract by 1, and add another 2, which is equal to the thing given. So this is just work checking. This is like one of the ways that you can check your answers when you're doing integration, which is to just differentiate it to see if you get back to the original starting point. Now I need to find the equation. After you've done this, we need to make it so that it satisfies this point, and integration also gives you a constant at the back. So right now we have y equals this plus c, and we need to find c in order to find the equation, and therefore we need to put in all the values to just solve for c. So y is 6 equals to minus 9 times 3 to the minus 2 add 2 times 3 is 6 plus c. And turns out that 3 to the minus 2 is just 1 over 9, which multiplied by 9 gives you 1, so minus 1 plus 6 plus c is 6, and 6 can go, and therefore c have to be 1. So the equation is y equals to minus 9x to the minus 2 plus 2x plus 1, and that's the answer to the third question. Now question 4.1, start with equilateral triangle and prove that cos 30 is root 3 over 2, and part 2 is solve the equation 2 sine theta equals to minus 1 for angle between 2 pi radian and 0 radians, and give your answer in terms of pi's. Okay, so for this one, let's say that this equilateral triangle have side length 2's, so 3 2's, and if I cut this equilateral triangle in half through the middle, then we know, because interior angles sum to 180 degrees, and equilateral triangles have interior angle 60, and I've chopped this in half, and we get 30, 60, and 90. And this is 90 because it's base opposite angle equal for isosceles triangle, that's the word. So we've got all these things done, and what I need to do is just to say cosine of 30 is equal to adjacent divided by hypotenuse. So it's, say this is x, which is equal to x over 2, and now we need to find x. Conveniently, because this is a bisect, we know that this is 1 and this is 1. And so using the Pythagoras Pythagorean rule, Pythagoras theorem, 1 squared plus x squared is equal to 2 squared. And that's just 4 minus 1 equals to x squared, and therefore x is equal to the square root of 3, plus or minus in fact, but x is a length, so it cannot be a negative, and therefore it have to be a positive, and therefore cos 30 have to be only positive square root of 3 over 2. So that's the proof. Now for this one, you just need to rearrange everything so that sine theta is the variable on the left. So we've got minus a half, and if you just use your calculator, set it to radian mode, arc sine of negative 1 over 2 gives you minus a sixth pi, or minus pi over 6, sorry. And for this one, it's a bit more tricky because you have to do between 0 and 2 pi. So let's just sketch a sine curve. I included the negative domain because right now our theta is negative, so it's sort of here-ish. And if you draw over the line, then between 2 pi and 0, you've got 2 points. And the way you find these 2 points is by adding 2 pi, you shift the whole curve to the right, so you get this point. So let's do that. Add 2 pi. You get 11 over 6 pi. And I said 11, but I wrote 16 for some reason because I'm just not doing well. 11 over 6 pi, and the other one will be pi plus a 6 pi, because this is symmetric along this section, and therefore since this bit is a 6 pi by magnitude, we know that this bit is 6 pi, and because we know that this point is pi, we add a 6 to get this particular angle unit. And so that would be 7 over 6 pi, and that would be the 2 angles that they're looking for. Question 5 is just a curve of y equals 2 to the power x, so that's exponential. On the copy, draw by a tangent to the curve at a point where x is 2, and hence find an estimate of the gradient of y equals 2 to x when x equals 2. Then, part 2, calculate the y value when x is 1.8 and x is 2.2. And hence calculate another approximation of the gradient when x is 2. Okay, for this one, I do not actually know how am I gonna do it on the computer, but let's do it nonetheless. So we know that we want to find tangent for line for 2, and I do not have a ruler, but I have a straight line tool that I can use. And that actually looks horrible. Yeah, this is near practically impossible, isn't it? No, 2 is over there, isn't it? This is actually ridiculously hard. Well, sadism can just laugh at me right now, just trying to put this line in place. That's good enough, I think. And so let's see what the gradient look like. I will say this hits this point because I am rough. Make sure you use like as fine of a pencil as you can when you're doing these kind of things. So I've got 6.2 as the y coordinate when x is 2.9. Is that 10 squares? 2.9, and I have a data point. Let's see which one is. That looks horrible. I'll just take this one because it's 0, y. Make sure you use like as accurate of a value as you can when you're doing these though. Like don't do me because I just can't see it on a computer. This is not 0.4 to 0. So I've got 2 data points. Now I find the gradients. So gradient m is equal to the change of x, change of y divided by change of x, dy by dx. So change of y is 6.2. Change of x is 2.5. Plug that in the calculator. Gets me 2.448. The answer is probably 2.5 or something, but I don't care. Now I need to do part 2, which use the y of these 2 values to find another approximation of the gradient. And so for x is 1.8, y is 2 to the 1.8, which is 2 to the 1.8 give me 3.48. 4822. Y equals to 2 to the 2.2, however, will get me 4.5948. That's 79, by the way. And to find that, just change in y divided by change in x. So that is 4.5948 subtract by 3.4822 divide by 0.4. Took me a while to do that one for some reason. That is 2.78. Just put 3SF because it's 14779 afterwards. So 2.78 is the second approximation of the gradient. Okay, question 6. S is the sum to infinity of a geometric progression with first term a and common ratio r, so a r to the n. And part 1 is another progression have 2a and r, and express the sum to infinity of this progression in terms of s. And also a third progression has first term a, common ratio r squared, expressed again using s and r, the sum to infinity. Okay, this one looks like it's going to be a horrible one, but it is actually relatively simple if you know how to like go around it. So we know that the sum to infinity of a sequence is the for a geometric is just a to the 1 minus r divided by to the infinity divided by 1 minus r. So if you use this equation, r to the infinity this whole thing equals to s from the question given, and now we just need to do the, find the expression for the series for the first part and the second part and compare it with s. So for part 1 we have a is 2a, so 2a times 1 minus again r to the infinity divided by 1 minus r, which are technically identical to s except for the 2. So this is also 2s. So that's relatively easy. So for 2, we have a equals a, then 1 minus r to the 2 infinities divided by 1 minus r squared, and that gives me r to the 2 infinity is just r to infinity. So this is, because it's 1 minus r squared, we can do factorization of the difference of two squares, 1 plus r, 1 minus r. That's what they want. And we can take 1 over 1 plus r out. And we're left with a 1 minus r to infinity divided by 1 minus r. And that is s. So we get s over 1 plus r as the second expression. Question 7, show a curve with these coordinates and use the trapezium rule using 6 strip to estimate the area of this between the curve and x and y axes. So trapezium rule is just half of the height or width of every strip times the first y coordinate, y0, plus yn, which is the last one, plus 2 lots of everything in between. And that equation is just, it's given on in the purple booklet, and you can just look it up if you want, or you can remember it. It's way faster if you do. So half of h is just, because you're doing 6 strip for 0 to 9, that would be 1.5 per strip. So half of 1.5 times y0 is 2.3, then yn is 0, plus 2 lots of everything between. So that is 2.9 plus 4 plus 4.6 plus 4.2 plus 3. And now just put them all in the calculator. Two 2.9 plus 4 plus 4.6 plus 4.2 plus 3, and that gives me 39.7, a half lots of 1.5 times 39.7, and that will give me an area of 29.775 square units. And finally, we have question 8. So y equals to gx, and we need to draw the graph of y equals g of 2x and y equals 3gx. Okay, let's start with g of 2x. For this question, I'll just use red for good reasons. G of 2x is horizontal stretch by a half, factor a half. So the height doesn't change, but the horizontal width does. So from -2, this point will be shrunk halfway to this point. This point will shrunk halfway to this point. This point will shrunk halfway from 4 to 2, and this one 6 to 3. And so part 1 looks like this. Part 2 I'll use glue. So 3gx is just a vertical stretch of factor 3. So everything is stretched from the x-axis by factor of 3. For this point, you go multiply by 3 up. So this is height 1 times 3 is plus 3. So it goes here. Same for this point. And for this point, 2, 1 also go to 3. For 4, 2 goes to 4, 6. Multiply by 3 of 2 is 6. And this 0 times anything is 0, so it stays here. And you just connect them. Remember to use a ruler. And that is all the question from section A. And there you have it, section A of a C2 paper. It's really not that bad. The nth term can sometimes screw some people up. This sum of, make sure you are familiar with what it is and how to do it. For differentiating, make sure you use the index form. If you don't use the index form, all the fractions such as this one will be practically impossible to logically solve. Yeah, for these kind of solved equation, make sure that you include every single solution. There are often 2 answers to the same question, so make sure you include those answers. And that's about it. These are all very trivial. 6 can be tricky, but that is also progression and summation. And yeah, that's it for this video. Hope you have learned something, and I will see you on my next one.